code. What we're going to be looking at in this part of 6.4 is just a continuation, letting you know that there is more on multiplying radicals. Right, and we multiplied kind of like a monomial radical and a monomial radical, but now we're going to take a look at multiplying like a monomial times a binomial, or a binomial times a binomial. So really, when we're multiplying other types of radicals, this is where we just want to kind of apply the distribution property. All right, so let's apply this distribution property. So let's take a look at some examples here. Let's multiply our first one here. How about the square root of 11, open parentheses, 4 minus 3 times the square root of 11, close parentheses. Right, so let's take a look at this example. So I'm going to rewrite the problem, right, just so we can see the original problem, right? And I mean, we've done a problem like this before. We're just distributing this square root of 11. We're going to multiply it to 4, right? We're going to multiply. Keeping in mind that the square root of 11, is some kind of a decimal, and 4 is the whole number, right? Because of that 4 not having a radical symbol, all we can do is kind of put that 4 in front of that radical. Okay, because the square root of 11 is really like a 1 in front of it times the square root of 11. And if we're going to multiply that by 4, all we're really doing is doing 1 times 4, bringing back that square root of 11. So that's why we get 4 square root of 11 there. All right, so that's really what we see in all those steps there. Any questions there, y'all? Any questions? Okay, now we do square root of 11 times this negative 3 square root of 11. Keeping in mind that both of them have the same indexes, so we can actually multiply. The 3 is the only whole number, right? So that goes outside the radical, and then the inside we have an 11 times an 11. And if you recall from last lecture, here we're pulling in groups of what, y'all? What is the index? When an index is not present, it means that the index is 2. So here we have 2 11s, which means that can come out. Right, we're bringing everything else down. And all we have left now is just to multiply this 3 times 11. Multiplying that there gives us a negative 33. We bring everything else down. Let me clean that up a little better. These are unlike terms. We can't do anything else, so that's our answer there. Any questions there, y'all, with that example? Okay, let's take a look at our next example. Anyone need a minute copying this down? Okay. Example B. How about now we do something like, I think this one looks nice. A little review. Third root of A, open parentheses, third root of 2a to the power of 2 plus the third root of 16a to the power of 2, close parentheses. All right, so rewrite this problem. Third root of a, open parentheses, third root of 2a squared plus the third root of 16a to the power of 2. All right, so we're going to multiply here. So they both have the same index, which means we show it once. Everything else goes in the inside. I'm going to show my 2a squared first, and I'm going to show the a afterwards. Any questions there, y'all? Any questions? Okay, now I continue. Now I'm going to multiply it to this next term, right? So it's plus the third root. I'm going to show the 16a squared first, and I follow by the a. Any questions? Any questions here? All right, now we're pulling in groups of threes, right? Take a look here. That definitely comes out, right? Leaving us with an a. All we're left with is a third root of 2. Over here, that a is going to come out. And if you take a look at this 16 is really 2 times 2 times 2 times 2, which means we can also pull out a 2. Right? So over here we pull out an a, and on this right side we pull out a 2 and an a. So the 2a comes out, leaving us with the third root of what's left uncircled, just the 2, because remember that 16 is gone. Any questions here so far? Right? And this is a really nice problem because it adds on some of the stuff that we talked about in this 6.4, right? Now both of these, right, we can go ahead and add those, giving us 3a, leaving us with the third root of 2. So a really nice example, this example B, because it incorporates some addition properties of radicals and then also some multiplication properties. Any questions, y'all, with this example? Any questions? Let's take a look at our next example. Example C. We have open parentheses, square root of 10, minus square root of 5, close parentheses, open parentheses, square root of 10, plus square root of 5, close parentheses. Once again, I'll just rewrite the problem. Same idea. I mean, we've distributed before. We're going to multiply it right there first, putting both of those 10s inside the radical. I'm not going to multiply it, right? I'm just going to kind of show it. Now we multiply over here, right? Giving us a positive, and we got 10 and 5. Any questions there? We continue on. The negative square root of 5 gets multiplied there, right? Leaving us a negative. Then we got 10 and 5 again. Their last one is right over here. Right, this is minus, then we have 5 times 5. Inside that radical. Notice here, these two are the same, so that's going to come out. Even in the last one, those two are the same. That's going to come out. I'm not even going to worry about the middle part because both of these are opposites, right? One of them is a plus sign. One of them is a minus sign. They both have 10 and 5, which means they give the same number. They cancel out. Don't forget to bring your minus sign down here. So this is just 10 minus 5, giving us an answer of 5. Any questions here, y'all? This example C is a very interesting one. This is a unique one, right? Notice that these are almost the same. And the only difference of the two is that one has a plus and one has a minus, right? So when we see, right, these radicals in that form, we call them conjugates. Right, so these conjugates are in the form of where they're almost identical. The only difference is really an addition and a subtraction sign. And when you multiply them, let me see. Here's the work, but this is the solution. A squared minus b squared. So let's take a look at this example again. Right? Do we have to show all of this? No. If they're conjugates, you can go about it an easier way. So the first thing that I would want you to tell me if you want to do it a different way is just say, hey, they're conjugates. Then after that, all you got to do is the first one, show it to me. Squared with the minus sign. Then show me the second one, squared. And what you will see here is that, let me show it on the next step. That this power of 2 and the radical cancel, power of 2 radical cancel, giving you a 10 minus 5, giving you an answer of 5. So under conjugates, you don't have to show all that work. Tell me that they're conjugates, and then just square root the first one and square root the second one. But now the question can arise, why in the world does that cancel? Right? And this is going to be very important in our lecture today, later on. Let's take a look at this power, this square root of 10. What is the index there? Index not present means that the index is what?
A 2.
Very good. Index is 2. That 10 doesn't have a power, which really means that the 10 has a power of what?
1.
Very good. Now, how can we rewrite this? Remember that we discussed last lecture how we can go from a radical to a exponential form. So how can we rewrite that radical as an exponential form?
Wouldn't it be 10 to the power of 2 over 1?
Close.
Or 1/2.
Very good, right? So that would be 10 to the power of 1/2. And don't forget, we have this 2 on the outside, so we bring that back. And then remember that we also talked about a rule that said if we have something like this, a to the power of m to the power of n means, let me clear that a little bit more. A to the power of m to the power of n means that we multiply them. So now here we just multiply. That's 10 to the power of 1/2 times 2. And if we put that 2 over 1, what cancels here?
The 2's.
There you go, leaving us with 10. So this cancellation process is really that work right there. Does that make sense, everybody? So in their conjugates, very nice. You don't have to show all that work. Tell me their conjugates, square root, square the first term, square the second one, and it should work very nicely. Let's take a look at one more example, just like that. How about open parentheses, 6 plus square root of 10, close parentheses, open parentheses, 6 minus square root of 10, close parentheses. So I want you to approach this a different method. Instead of working it all out, let's just say that these are what then?
Conjugates.
Very good. And because they're conjugates, all we have to do, right? First term, square it, minus sign. Second one, square it. Right? 6 squared gives us 36 minus what happens on the other side? What cancels?
The 2's. The
Good.
square root and the square.
Good. Very good. Cancels out, leaving us with 10. 36 minus 10 gives us an answer of 26. Right? So when they are conjugates, very nice. Once again, you can show your work this technique. If you're going to show your work this technique, you need to state conjugates, because that tells me that you understand that term and you understand what to do, right? So you can show your work that way, or once again, you can just actually work it out. You will see some problems on your exam on conjugates, because that's something that we want students to understand by the time they complete a college algebra class. Make sense, everybody? All right.